Hello, thank you for joining us for this session, Getting to Zero Energy in Schools is Achievable, Stories from Schools on the Path to Zero. I am Connie Umphris, Communications Manager here at New Buildings Institute. Before we begin, I have a couple of housekeeping things to tell you about. First, you are muted and we cannot hear you. This helps keep the background noise down so everyone can better hear our speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know and we will help you as we go. We will take a few questions at the end of the presentation. Please ask questions in the same question pane. Please take a couple minutes to answer the survey that will pop up at the end of the session. If you are seeking AIA credits, this is where you will enter your AIA number for credit. All registrants will receive an email tomorrow with links to the recording and slides for this session. Kicking off today's session is Riley Loveland, NBI Project Manager. Riley supports NBI staff on various projects, including K-12 schools-related work. Riley also designs and develops NBI workshops, public engagement materials, and other technical and market transformation resources. Over to you, Riley.
Good morning, everybody. Thank you, Connie. Happy Monday. For those of us on the West Coast, it's a little early, and for everyone else on the East Coast, it's about lunchtime. Like Connie said, my name is Riley Loveland, and I'm a project manager over here at New Buildings Institute. And this webinar today is brought to you on behalf of National Grid. So a big thank you to them for making this webinar possible. There we go. So for those of you seeking continuing education credit, here are the learning objectives for today for you to refer back to as needed. And I wanted to quickly mention too that we have one more webinar coming up soon. We'll probably have more in the future, but this one is on the schedule. Please check out our website to register for financing approaches for getting to zero in schools. So zero energy schools is a very attainable goal for schools across the nation. NBI maintains the largest database of zero energy buildings in the nation, and the data clearly shows that this educational sector, what we're focusing on today, is leading the market as this whole building sector transitions to zero. This data will be echoed by our presenters today, but for reference, a zero energy verified building is a building that has demonstrated 12 or more months of zero energy performance. And then from the ASHRAE Zero Energy Design Guide for K-12 schools, zero energy schools are feasible at an energy use intensity, or EUI, of 25 kilobTUs or kBTUs per square foot per year or less, depending on your location. So that's what we generally recommend, is 25 kBTU per square foot per year when you're setting your design targets. The zero energy verified buildings are in green on the left, and you can see have a median energy use intensity, or EUI, target of 18. Actually, this is not a target. This is what they have actually been designed and are operating to. So a zero energy emerging building, the ones in blue, is a building that has not yet demonstrated 12 months of zero energy performance because they might still be in design, under construction, or have not added the renewables they may need to actually get to that zero target. And with these buildings, we're seeing a median EUI of 28. From the research that NBI does on these zero energy buildings, we've been able to identify some common themes across these successful zero energy, new construction, and retrofit projects. This is a list of these common steps that those on the path to zero energy can utilize as they work to get to zero. And our presenters today will go through how their projects utilize each of these steps in their own way to achieve the goal of zero. It's important to know that not everyone follows the steps A, B, C, or D, that every project is different, and that you can use these common themes to guide your own project. So quickly, I wanted to let you know that we have a suite of resources from NBI and other sources for schools to get to zero. These slides will be available online after you to dive deeper. However, I'm just going to blow through them really quickly because our presenters are significantly more interesting. So we have the Getting to Zero Resources Hub, a list of Z&E case studies that are school specific. We have other case studies too, but for the purposes of this webinar, we have school specific ones. We have the 2019 Zero Energy Schools Watch List, which showcases all of those Z&E verified and emerging schools. And then a bunch of other tools for zero energy schools and guides, like the Integrated Design Charrette Toolkit, a stakeholder messaging guide, and a project guide. Additionally, zeroenergy.org is hosted by the Department of Energy, and they have a similar suite of resources on their hub, including the Zero Energy Process Guide, which is a nice complementary piece to this Advanced Energy Design Guide. This one is really specific and really technically guided. It's the prescriptive path sorted to get to zero energy schools, and the process guide is its kind of complementary process-focused document. So on that note, I would like to introduce today's presenters. We are thrilled to be featuring Jeremy Shannon, who is the Director of Sustainable Design from the New York City School Construction Authority, and Jacob Knowles, who is an Associate Principal and the Director of Sustainable Design at BR+A Consulting Engineers. So on that note, I'm going to hand it off to you, Jacob, and I'm going to physically hand it off to you here on the webinar.
Great, thank you very much. So we're going to talk about a single case study. It is a community college in Fall River, Massachusetts, and it's a new building on their campus. Just trying to proceed. There we go. So you can see it's a commuter campus. All of the buildings were built about 50 years ago, and this is the first new building on their campus since that campus was built as a whole. It is a teaching environment for dental and medical education on the first floor. So you can see some of the program for the dental clinic that serves the community, and also the nursing arts classroom. And on the second floor, it is all wet laboratory, teaching laboratory space. So it has biology, chemistry, microbiology, and all of the relevant support spaces for that program. You can see one of the chemistry classrooms here. So this project began almost 8 years ago. And when it began, it was not a net zero project. It was a state-funded project that had to be at least better than code by 20% and LEED silver. So it had all of the things that you might expect in a typical high-performance, quote-unquote, high-performance design. So it had high-efficiency air-cooled chillers. It had condensing boilers that burned natural gas. It had runaround heat recovery for the lab exhaust. It had enthalpy wheels for the first floor, heat recovery on the ventilation system, and efficient lighting, a decent envelope, all the things that you might expect a project to have to hit that 20% better than code requirement. And then the project went on hold, awaiting approvals and funding for over a year. And when it came back to life, the college had doubled down on their commitment to achieving carbon neutral by 2050. And the first major step in that effort was they were entering into a power purchase agreement to have a 3.2 megawatt solar array installed on the parking lot directly next to the site where we were going to build our new building. And so that became the sister project to our project and inspired us to take a second look at our design that we had initially started with. So we thought, well, we've got this great high performance design, so we must be helping them on their way to achieving their carbon neutral goals. But just to double check, let's do an energy model. And we did an energy model of the new building, and we determined it would use about half of that entire 3.2 megawatt solar array, plus 120 homes worth of natural gas. Let's just say that was not a happy moment. So we said, okay, we're clearly going to have to do better. So let's come up with a whole new design for the building that helps them achieve their net zero energy goals. So we did. We put together a package of systems that we'll briefly walk through today that allowed us to greatly change the energy consumption of the building. So first of all, we needed to eliminate the use of the boilers and we instead installed a geothermal system. There are 30 500-foot deep closed-loop vertical boreholes next to the building, and this is the heat pump chiller skid that connects to the bore field and produces hot water and chilled water to serve the needs in the building. Now, in a building with lab space, which even a lot of high schools have, it can be a big driver in terms of the energy consumption. And so we needed to address that. Standard practice would be 6 air changes per hour all the time, and ducted fume hoods exhausting to the atmosphere with mediocre heat recovery systems typically. So instead of that, we were able to install an air acuity system that monitors the air quality in the space. And therefore, when it's clean and safe, we're running at 4 air changes per hour instead of the typical 6. And at night, we're running at 2 air changes per hour. And we're monitoring the air quality in the space and providing feedback to the users. So if they are accidentally exposing themselves and releasing chemicals into the air, there's actually a feedback system to tell them that, rather than just flying blind and not having any information. In addition, we're using filtered fume hoods that chemically adsorb the chemicals in the fume hood onto an activated carbon filter, and then returning clean air back to the space. And this is a technology that's been around for almost 50 years. We've used it in many of our projects now. There's hundreds of applications throughout the Boston area. So between those two strategies, we've actually provided a healthier, safer environment that also dramatically reduces the energy consumption for the building. Now that we've addressed that air change rate and exhaust demand, we know that the cooling load in the space can also be a driver for how much air has to be brought into the space. And so instead of doing an all-air VAV reheat system, we installed a dedicated outdoor air system. And at the zone level, we have fan coil units to do supplemental heating and cooling. And that decouples the conditioning for the space in terms of thermal comfort from the ventilation of the space to provide fresh air. In addition, because most of the fume hoods are now filtered fume hoods, all of the exhaust from the building, except for the 4 ducted hoods that remain, all of that general exhaust air from the room is just clean room air. And so you can use enthalpy wheels for heat recovery, which are far more effective than a traditional glycol runaround system. And so that, again, further reduces the loads on the building. Now that we've addressed the 500-pound gorilla of the exhaust and makeup air, we also needed to address the other end uses in the building. And so one of the drivers also is the lighting. And we were able to achieve a lighting power density of 0.5 watts per square foot in the lab spaces, and that still was able to maintain generally over a 50-foot candle level at most of the work surfaces. And it got to about 0.6 watts per square foot overall for the building. We also did a detailed plug load study of all the equipment that would go into the space. So that includes things like hot plates and refrigerators and centrifuges, medical and dental equipment. And for each program, you can see across the x-axis on the bottom, we stacked up what are all those end uses adding up to in terms of watts per square foot, which is shown on the y-axis. And our original basis of design was 8 watts per square foot, again, not really knowing all of the equipment that might go into those spaces in the future. But by doing this detailed study, we were able to more accurately define those loads and reduce the wet labs down to 6 watts per square foot and the dry spaces down to 3 watts per square foot. We've since been monitoring the actual operating data, and if you take the entire second floor looking at the wet labs and the support spaces, it's actually on average never exceeded 1.75 watts per square foot. So subsequent buildings we're now designing at 4 watts per square foot instead of the 6. Now in this building, because we've addressed all of those big drivers in terms of loads, the envelope really starts to make a big impact. And so we wanted to at least meet the energy code under which the building was permitted. Now that may not sound very net zero, but surprisingly, most buildings don't actually meet the code under which they're permitted. There's an issue, at least historically, with design teams calculating the thermal performance of the envelope assemblies, not accounting for all of the thermal bridging. So if you look at just the space where all the insulation is, sure, you might meet the code. But if you forget to account for the Z-girts and channels and relieving angles and all those things that go through the insulation, then you're missing the fact that your envelope typically is not in compliance. And so we wanted to at least make sure that we were meeting the code. And you can see in the bottom there's a chart, the stud walls versus mass walls, looking at the baseline effective total assembly R value in yellow versus our actual design in blue. And since this, of course, we've continued to increase the thermal performance of our envelopes. So, got a little hiccup here. All right. Now, in addition to the thermal performance, we also wanted to make sure we had an airtight envelope. And so there's a lot of effort paid attention during the construction process to make sure that everything was sealed properly. And they did a blower door test at the end, and we outperformed our specified performance, which was 0.23 CFM a square foot at 75 pascals. And that blower door test came in at 0.08 CFM per square foot at 75 pascals, which is in between the two passive house standards you see here shown. So very tight building. On the opposite end of the spectrum, we also have natural ventilation. Now that may seem odd for a building that has a lot of laboratory space in it, but we did not apply it in chemical use areas that have fume hoods, but we applied it in many of the other areas. You can see here on the first floor, in blue arrows show all of the manually operable windows, including the dental clinic and nursing arts, CLS teaching spaces. And then there's the central atrium space, and that's a fully automated system with motors that actuate the windows. And you can see here a diagram of the flow taking advantage of wind and buoyancy in the atrium space. We have a weather station on the roof that then tracks the outdoor air conditions to determine when it's appropriate to open the windows. So ultimately, compared to the original design, we eliminated 70% of the energy consumption, and we're able to turn off the boilers. The real question was, can we afford all of this? As I mentioned before, the project was approved and permitted through a very long and painful process with the state funding the project, and there was no way to change the budget to get additional funds to achieve net zero. So we developed, at the request of the state, two designs through schematic design. One was the original high performance design, and the other, the net zero design. And the cost estimator put together a detailed line item cost estimate comparing all of the components of the two systems. And the net zero design came in originally less expensive than the high performance design. Now, of course, that turned out to be a little bit too good to be true. We went back at the end of construction with all of the final construction costs and updated the analysis. And it turned out that the cost premium to get to net zero was $275,000. But that is 1% of the construction costs for the project. That still seems too good to be true, but if you look at this graph, what it's showing on the left is all of the things that we were able to do to reduce construction cost. So the air handlers went from over 70,000 CFM down to 24,000 CFM by reducing the loads and by putting fan coil units in the spaces. We also reduced the size of the penthouse. There originally had to be two penthouses, one on either side of the atrium, and we were able to eliminate an entire penthouse. We also eliminated the conventional air-cooled chiller and reduced a significant amount of valves and ductwork for the lab air. And then we took that $3 million in savings and reinvested it more wisely in the things that do cost more for net zero, which included the geothermal system, the ground source heat pumps, the air source heat pump supplement, and the fan coil units. We then pursued utility incentives and grants that more than covered that 1% premium, and that allowed us to add fully adjustable lighting control system and a metering and monitoring of all the systems so that it could become a case study for the state. And then if you look at the operating savings of the building and the fact that the power purchase agreement offered them electricity at a lower cost per kilowatt hour than if they had paid the utility directly, that results in $4 million in net present savings over 20 years. And on an annual basis, that $230,000 a year in savings is equal to the tuition for 50 students. So I always jokingly say to the CFO when I go to Bristol Community College that I wonder if he's set up his Zero Net Energy Scholarship Fund yet, because it's having a real triple bottom line benefit to them being able to serve the community, not just reduce their carbon footprint. Since operation, we've been monitoring the energy performance of the building, and it is performing as anticipated. The building is running at an EUI between 45 and 50 kBTU per square foot per year, whereas a building typically of this type would be well over 150. So it's actually running energy positive at an EUI of negative 13 based on the small percentage of the overall solar array that we allocated to the building. And the rest of the campus has been able to use the remaining energy from that solar array. One of the other interesting things, lessons learned from this project, was just how important energy storage is going to be in the future. As more and more buildings achieve net zero energy and electrification becomes critical for that, you'll see on the left, each of those green spikes as every hour or every day of the year as the solar array produces and exports energy onto the grid. And the blue line is the energy consumption of the building. So if every building ran like this, we would melt down the grid, basically. Even though they're roughly balanced on an annual total, those spikes when the solar is producing are dramatically higher than the building's energy consumption. And so energy storage is going to be a critical piece of flattening those spikes and matching up demand with supply.
Okay, great. It looks like it's time for my section here, so
It's on to you.
I'm gonna cue it up. So as mentioned before, my name is Jeremy Shannon. I'm the Director of Sustainable Design at the New York City School Construction Authority. Many people might not know exactly what we did, because before I started to work here, I didn't know a lot about what we did. But about 30 years ago, the New York City School Construction Authority was separated out from the Department of Education, specifically to focus on the capital construction work that the city does. And we actually build about anywhere from 15 to 20 new schools a year. About 1 million square feet of new schooling every year is built in the city because of the city's rapid growth, which was a surprising figure to me when I came here. And then we also maintain the existing capital infrastructure for the 1600 to 1800 various buildings, school buildings and structures that we have. So the focus of this talk is really going to be on this one pilot school that was done called the Catherine Grimm School for Leadership. It was started design in 2012, I believe, and then kind of wrapped up design 2013. I am, let's see, try to move the next slide here. There we go. So this was a really unique site for us. It's in Staten Island, so of the 5 boroughs, this is the one where we have the most land per school area. A lot of our sites are much more urban than this, so we had an opportunity here that those at SCA at the time decided that this would be a great time to try and pilot a net zero school, because we could actually, our program here was a 2-story or maximum 3-story program, and we had parking space and a little bit of play space. So we felt that there were opportunities here that we often don't have in kind of our dense urban setting. And we thought that this would be a great place to pilot and learn some other technologies that we hadn't been using at the time. Just some of the pretty interesting images here. This the design was done by SOM, and I think they did a great job with kind of really trying to integrate this new way of trying to show that the the PV systems didn't have to be something that you hide away. They were really trying to highlight it for the community, but also understand that they were in a residential area and trying to kind of keep things back from the street and delicate to the space around. So the building square footage here is 68,000 square feet, 26 classrooms. It's a typical school, PS school for us, elementary school. We do have a full kitchen and cafeteria. One of the things with our facilities is that we really use our kitchen and cafeterias quite extensively. We have breakfast, we have lunch, now we have some dinner programs for the community. And we also have summertime feeding programs that are available for those that want it. So our kitchen and cafeteria energy usage is quite a bit higher than some other schools that we had studied for the net zero research that was done. One thing that I was surprised about when I first was looking through this project when I came to work here is I'd seen a lot of these beautiful renderings that had been done, and I thought that they were not photographs but actually renderings. But these are actually photographs taken at the school, and then when I went to the school, I realized, wow, this school actually does have amazing natural light coming into it. It's a beautiful space. They kept the corridors very open and airy so you could kind of get that connection between floors. So the design was really well executed. And since I wasn't the architect, I can pat ourselves on the back that way. Classroom here. So one thing you can see in this image of the classroom is that we had kind of the vision panel glazing down there that you see kind of at the kids' eye level there. Then we had kind of a blocked out panel here, which the teachers have really enjoyed using to kind of put up the different images of artwork and stuff that the kids are doing without having to have putting that stuff on shades, which they do at a lot of our schools. And then in the top part, we have a Solera glass there that's really adding really beautiful diffuse lighting coming in that integrates with the slope ceiling that we have. So this image here, you can see shows how it's a little zoomed out here, but we actually had the interior in the classroom spaces where we sloped these ceilings down, so as that light came in, it really reflected as far back into the excuse me, as classroom as possible. So for some of the overview of the systems, this actually was our first attempt at geothermal systems. And so there are 80 vertical wells here going 400 feet deep. And this was put in place where the play yard was going to be and where the track is. And that was a relatively successful location for it, because in that way in future, if we ever have to do any work on those, they're accessible, they're not underneath the building. The electric panels that we did were 2018 panels that are up on the roof initially, and then we actually since then added another 68 panels. And the note here says in place of solar thermal roof spacing. I'll talk about this a little bit later as I get into lessons learned. But one of the things that we're doing here with our kind of overall monthly coordination that we're still doing 3 years after occupancy here is constantly monitoring, see how we can improve the space, how we can make things better. And one of the things we saw wasn't working for us was our solar thermal system. So I'll get into that a little bit more in the lessons learned. So we're still trying to make sure that we improve the building on an ongoing basis. So it's not just a design it, leave it, and hope it works for the best. This is a continuing process of improvement. We have an energy management system that is monitoring all the different circuits in the building. And this is another area where we had an issue that the design looked like it was gonna be great, and we're gonna be really able to learn incredibly aggregated information about which circuit is providing which energy when. When we plug stuff in, we're really gonna be able to understand our plug loads much better. And then we had some contractor issues with the lowest bidder, since we're public procurement, and that I will also get into a little bit more too. Not to focus on the bad things, because this ends up being an amazing project, and we're still learning from it and learning a lot about it. Enhanced commissioning is something that this was our real first chance to do beyond kind of a standard lead commissioning, lead equivalency that we do on all of our projects since 2007. But we're really focused on the envelope commissioning here that we hadn't done before, the blower door testing on this school. This is before it was required by our code for certain size buildings. And I'm going through a lot of these slides. I have some more information that I'm not gonna touch on each slide, but I wanted you to have this as a resource to go back and look to. But I wanted to get to the lessons learned too. So if anybody has questions about some of the things I might have skipped, feel free to let me know afterwards, and I'll go back to it. So we have a monthly consumption generation tracking, and so this one of the things that's been really great about this project is right from the beginning they realized that they wanted to have more than just our standard operating custodial staff involved in this project. And so we had an energy manager, Bill Horan, was the one who was hired for this project. He actually put together most of this presentation and has been integral to making sure that these kind of lesson learned have been tracked and are continued to be reviewed on a monthly basis. And so he was the Department of Education staff that was on site kind of towards the end of construction, as well as then carrying it into construction, carrying it into occupancy, and is now continuing to monitor it. And having somebody that understands all of the systems, understands what the design intent was, and then is somebody that's working directly with the custodial staff that's operating is a really key component that everybody should try and kind of force into the process when you get started. For our net zero achievement came when we were in 2018. The building was occupied in May 2016, and so at about it was not quite 2 years in, finally, after we had a running 12-month period where it actually was net positive. And what we saw was that this graph here shows the dashed line, this 12-month net energy. If you look to April 2017 here, what happened is that this is actually the time where the contractor largely stepped away, and so they had reached substantial completion. And when the commissioning agent started really focusing on all of the functional performance testing, going back with the contractor and their subs to make sure everything was being tweaked. And you can see this rapid reduction across that line when we're doing that enhanced commissioning process. So the period before that is where we got the kids in, it was occupied, the contractor was finishing up the large amount of their punch list. But if we had just left it at that point and the commissioning agent hadn't done the advanced research and follow-up that they had done, we would still be operating well above what we expected to be operating at. So that was pretty exciting to see that sort of direct correlation, because then in my position, that really makes it so I've got something to fight for in future projects to say, you know, this sort of building envelope commissioning as well as the enhanced commissioning really makes a difference, really pays for itself. And so let's make sure that that's baked into all of our future projects. So one of the really important things about this process is you want to make sure that you have all the stakeholders involved during design, and that process really was done well. And we want to also, though, don't want it to drop off and everybody moves off to another project right afterwards. So something that happened in a good way here too is that this sort of monthly follow-up, once things were kind of at that substantial completion, has been ongoing, and we've kind of taken stock from every different group of every stakeholder in this process. So we've got the operations team, we've got the engineer, the architect, the principal and her staff. So I think the only thing we don't have on this lessons learned here is the students. We don't have their input on this slide deck yet. But I wanted to highlight a couple things from each of them because there's a lot of information here. But the it's interesting as we go through it, there's interesting to see the different types of information that people were focused on and different things that they were concerned about. So the manager of operations, interestingly, for them, the heat pumps were a new system to them that were being used for this geothermal system, and we were very much used to kind of steam boiler systems. Back in maybe 2012 when this designed, we weren't really doing steam boilers anymore. We were doing more kind of gas, hot water boiler systems. But the custodial staff from Department of Education, they jump around from building to building. Pretty much the custodial staff will only be in a building for a couple years before they kind of move to another one. And it's part of the way it's built into their advancement is that as they move to a bigger building, they get more seniority, more pay, that sort of thing. So unfortunately for us, as the builders of these buildings, it means that we don't really get to see a custodial staff that's going to stick around for a really long time, typically. And so to have systems that are new is something that definitely, even when we're trying to train them, it causes some lost in translation things that have to be worked out. For our construction management team, this is our SCA owners rep. They're also highlighting that some of the pump room issues were not understood very, very clearly right from the beginning, and the design actually had some issues where they were they had kind of run the piping not as it was expected. So there are some areas where you actually can't get to some controls and had to be adjusted in that way. The water and the solar thermal panels was run through the solar panels as a test them for leaks. And at the time, they didn't realize, since we hadn't used solar thermal systems very much at all, I think that might have actually been our first one in any of our schools. They didn't realize that had to be the kind of glycol coated systems, because even when you then drain them down, there's some water that gets in certain elbows, and so it caused some leaks that happened that had to be fixed afterwards, and some manufacturer issues there. So some of these things, as we track them, have been super helpful to try and say, well, if we're going to do this in the future, let's make sure we get all of this information to the design team that's going to be doing the next thing. And we actually are very standards based here, since we do so many schools in a year. We try and deliver, and this is actually available on our website to anybody who's interested. But at the nycsca.org, we have kind of our standard details and specs, and a lot of these lessons learned have been incorporated into those standards to try and get some of these things baked out of the process there. Infrared testing was one of the things on that the SCA thought we should have done when we were doing the air vapor barrier installation before we put on the building skin. And that's something that we'd never done before, but it's something that after the fact we realized it would have made it easier to search for envelope leaks after the fact. I know that this building did actually more than exceed its airtight numbers, and I was realizing as Jacob was telling his numbers there that I didn't have that number offhand, so I'll actually get that number that we achieved in the blower door testing and then give that to Riley, and we can kind of put that as a posting. So if anybody's interested, they can find out that information. So moving on to the engineer here, I guess they had less issues. They were more happy with their efforts. The pump balancing and controls again were an issue for everybody. I think actually this is coming up for everybody, because when you looked at that red dash line that I was showing where we were dropping our energy consumption quite precipitously back in 2017, what that really quick drop was from is that we were realizing that the pumps for the 10 pumps for the geothermal system were all running 24 hours a day and not following their control sequences. So for about a year before that got fully commissioned and fixed, those pumps were running constantly. So if we hadn't continued to circle back on that, that's something that to this day would still be running quite a bit. And then, I'm sure some energy manager or somebody somewhere would be wondering, wow, this building was expecting to go to net zero and it's not there. So that was a really important finding to get that corrected. Let's see, there it goes. So the architect, owner's rep, the process here was actually a really interesting process for the SCA. And I think back at the time, I'm sure SOM had done kind of similar charrettes and that sort of thing. But very early on, even though we couldn't bring in a contractor for this, since we're basically a design bid build agency, we were able to actually talk to a lot of the manufacturers. So this project was one of our first precast panel projects that we had done, trying to standardize some things so it wasn't just a brick and block type of building, which is what's our standard. And so bringing those manufacturers in early to the process, bringing all of the stakeholders in early was a really good lessons learned, that it was something that I know the architect of record was saying was very useful, as well as the SCA has found that process was great. And what we found is that there's a parallel with the new LEED V4 and V4.1 rating system, which we build to kind of an equivalent standard called a Green School Guide. And in there, we've have the integrated design process, which is the meeting that we have right in the beginning, kind of in pre-schematic level, and then we try and carry that process out at each design meeting, looking back to those original goals that were set. And that's a very helpful way of working that kind of this net zero project was doing before that was really part of our standard. And that really helped us kind of explain how that is important and why we should continue to do that for each school. So the commissioning agent is saying, hey, you guys should have brought us in earlier. They were involved in the design too, but I think as everybody was waiting for the dust to clear after just getting the students in before school started in September, and then also having the contractor finish up the key kind of visual and other quality of life things that needed to happen, the commissioning agents weren't brought in early enough to kind of focus on those pump issues or some other things, because the contractor and everybody else was focused elsewhere. So if we can come up with a way to try and accelerate that earlier time frame and get things moved up, that would be great. We have a very constrained design process, so even for this one, it was a 12-month design, and then it's out to bid. So we don't give anybody for a one of these 70,000 square foot to 100,000 square foot schools any more time, because we have to kind of have a 3-year turnaround from the time that the pricing is allocated, the funding is allocated to actually get those students into the school. So having a little bit more time in design would have been great too, but also a little bit more in construction to be able to get some things done earlier that were critical to building occupant use before they get in. So that way then, before the building is actually running continuously, to really be able to get that sort of commissioning done on all of the systems. Definitely would have saved some energy in the first year. Some of the other things too, we were using kind of some proprietary systems, which we normally don't do. So we had to get some special permission for that, since this was kind of a little bit leading edge in different technologies. And the one thing that we also use that Jacob mentioned that they were using was the air acuity system for CO2, and so that worked pretty well. I think it was working pretty well for the first couple of years. I know they've had a couple problems now recently where some of the lines are having issues, and they're replacing some of those, but overall I think the system worked well. What we're actually happy about now is the evolution in the industry, where now we can put in more localized CO2 sensors that are actually much more accurate than they used to be at this time when they were designing this in 2013. And so we don't actually have to go to a whole building type system like that, but just have a CO2 sensor that's really operating kind of a in-room damper that can kind of damper things down and then kind of send feedback back to the main units. So for the facility engineer, they were having a lot of issues with the solar thermal system. You know, part of it I already mentioned was the initial testing. They had the contractor ran water through it, so had to fix those issues. We had situations where I don't think I think it was oversized for what they thought our load was going to be. So what we're finding in New York City is that typically we don't use anywhere near as much hot water, domestic hot water, than the ASHRAE standards suggest, based on kind of type and square footage. And so the design was based on the ASHRAE sizing, and so we had two 650-gallon storage tanks in this school for maximum 600 students, and that kind of 1,300-gallon capacity ended up causing a lot of problems for us. The water just wasn't circulating through fast enough. Plus, we ended up having the local water supply, since it was actually towards the end of a run in Staten Island, had some quality issues that were unrelated to the school, that were just based on the neighborhood, that sort of storage capacity caused problems for. And then having the solar thermal to try and keep up with keeping that much hot water at the right level became an issue for us, which is one of the reasons why we went through and said, okay, the solar thermal system, yes, we invested good money in this. However, it's causing a lot of problems for the staff to be able to handle it and maintain it. The glycol was having to be changed more often than it should have. And so, for those of you who love solar thermal, I'm not saying solar thermal is bad. I'm saying in our situation, it was not something that our staff could really handle from a maintenance standpoint, as well as I think because of the sizing issue with it, it was a little bit of a mismatch. So we removed the solar thermal just recently, actually over this summer. We removed those two large tanks, and we've now switched the kitchen over to a kind of a small 100-gallon heat pump hot water. So it's a storage heat pumps, A.O. Smith, Rheem, Rudd, a lot of these are out there. They're making these kind of packaged units. We located that into the kitchen, so that way actually the air source side of that heat pump can take advantage of any excess heat that the kitchen has and draw that in. And then we put point of use electric systems in for all of the bathrooms. In this school, because it has a decent number of pre-K and kindergarten classrooms, they all have individual bathrooms with one sink. And so those sort of separate point of use electric heaters, when we did the energy modeling, and it actually looked like it was a good way of minimizing our energy losses through a distributed, larger kind of loop distributed system throughout the building. So for the principal, her focus was on looking at how how did the technology integrate with what the kids were expecting to see and what the educational components were. There was interesting that there was a bike room in there, so a bike charging room, and so the kids can get on the bikes and they can pedal the bikes and they can see on a graphic display how much energy they're generating. The initial design and thought on that was that the bikes were actually going to provide electricity and generate a battery that could then be used to generate real electricity for the school. Turned out that the amount of biking that those kids would have had to do and the pace of biking those kids would have had to do would have been so much that they probably would have all fallen off the bikes and passed out in order to have enough electricity to actually be able to push back towards the grid. So we created the bikes actually do show on the display how much energy they're generating, but it's not actually that electricity is not being generated, it's just being tracked, so they can see what they would have been generating by their exercise and effort. So that way, it was just a way of tying into them how this sort of work turns to energy and electricity. The other thing is we have graphic displays throughout the building that kind of show them how what different things are working around them. The principal notes here that she was upset that the windmill wasn't able to be installed. So there was an outside windmill that was going to be put out there. Unfortunately, when the wind studies came back, they weren't optimal for windmill installation. And so really it would have been probably taking more energy to keep the windmill turning than the energy that it would have generated, because the wind of the site was a little too sporadic. And so that's something that it was, definitely an educational opportunity missed to see that windmill going. But I think we have a lot of different points around the school that show about the photovoltaics and the ground source heat pumps and that sort of thing. So throughout this process, I mentioned that we had the energy manager, Bill Horan, who is kind of tracking things and making sure that the systems were running optimally, that things were being turned off when they should. So the data that was being given back was great for this. I won't go into great detail on here, but some of the things he's showing are that, if you look at the purple line, so the pink line that's kind of tracking very similarly to the blue line down below, what that is he goes into here in the details that it's, if things were running optimally, they could get down to the green line, right? So he's basically saying that you can kind of shave these peaks off, and we're able to track where the CO2 is spiking. But if you don't see that the actual equipment is tracking down with or tracking up with those CO2 spikes to provide more ventilation, and then tracking back down when the CO2 is showing that nobody's in the room, then that's the sort of things they're looking for in this graph. And those sort of triggers have been really helpful in the kind of the ongoing commissioning to make sure that those systems are still operating properly. I'm going to move past this one here. So, before I go into kind of where other projects are going, one last thing that I wanted to say about where we've been trying to evolve this project is that when this project started, the kind of the exchange rate here was a PV panel. How do we limit the number of PV panels that it takes to make this school net zero? And that really became a really important driver to all the design decisions. Everything was kind of not turned back to a cost, but turned back to that PV panel, knowing that we had very limited space to be taken up. So with that 2,000 panels that were put on, that was over the facade as well as the entire roof of the school, and then it was also over the parking space, as showed in the earlier photographs there. So that was really a good guide to kind of keep in mind, is like, what is the metric that you're working on to lower these things. So that metric has shifted a little bit for us now recently. We've been really focused a lot on how do we go and start looking to fossil fuel free schools, which is why we were kind of switching out. So that solar thermal system that was there for the domestic hot water, the backup to that was 2 gas boilers. And those 2 gas boilers were only supposed to supplement, but because there was so much water there that wasn't being used, but there were standing losses, and because the time that the energy was being drawn out of those machines, the boilers continued to kind of short circuit our process there and use a lot more therms of gas than we actually intended and wanted to. The other thing is too, when the custodian changed about a year ago, after our net zero status, the new custodian came in and didn't understand what all of the heat pumps were there for and the pumps, and there was a manual shut-off, a manual switchover, which they could actually switch the 2 boilers to actually switch into heating mode and not just doing the domestic hot water backup. Well, being somebody who came from a boiler building, the only thing I can assume is that just that seemed familiar, and so they flipped that switch and they ran the boilers for months to heat the building and underused the heat pump system. So luckily, because we do our monthly tracking, we started to see these spikes, and we were able to say, with these spikes, there's something going on, and that's when we were kind of evaluating, we realized that we needed to actually get these boilers out of the process and get all of this gas out of the out of the equation. So the domestic hot water now is fully gas-free. We now have the 2 boilers are still there, but there's basically like kind of a locking mechanism on it that really it's just like break in case of extreme emergency, basically, to use this for the heating system. So it's really only if the geothermal system goes down, because we've had no problems with that maintaining even in the coldest time period at this point. So in the last minute here, what we've done is just taken a lot of these lessons learned. We're working on 4 schools, about 500,000 square feet that we're in design right now that are actually going to be using a lot of these very like high performance building envelope, triple glazed windows, good R30 insulation for the walls. We also then have 3 existing public schools that we're doing high performance envelope overcladding and trying to learn how we can take all of these, existing 1,600 buildings and make them high performance. So that's a really interesting learning method, and a lot of it came from where we had the panelized rain screen system on this school. We saw that we can really get a lot of facade up quickly with a very panelized system, and it doesn't necessarily have to be panelized concrete. It could be another panelized system. And then we also are trying to move a lot of schools to fossil fuel free using heat pump technologies. And then we have 2 schools that are undergoing full deep energy audit retrofits that we're hoping to have largely done by 2025. Those are in design right now. So that's all I have. Thank you.
Thank you to both of our presenters. Wow, that was incredibly interesting. This is Riley Loveland again. I'm trying to get the slides to go. There we go. We are a little low on time, so I think we will ask, actually, I'm going to take that back. So I think what we'll do here is we have a few questions for our presenters. So I think we will just put them into a document, have our presenters answer, and then post them on the website and follow up, like Connie said, with some links for all of you to review, and that'll give them some time to give a really long and thought out answer too. So unless there are any more last comments that either Jacob or Jeremy wants to say, we can probably call it a day. Anything from either of our presenters?
Thanks for having us.
Great.
Yeah, thanks for the opportunity.
Thanks so much. Have a great day, everyone.
You too.